Today what we're going to do is we're going to start Chapter 1, Section 1. The standard that we're mainly going to look at this section is definitions. We're really going to see special definitions that are found in geometry. So first of all, what we're going to do is we're going to look at a definition of point. Point has no size. Think of it as a location, and it must be named with a capital letter. So an example of this would be, let's say I have this point, and I'm going to name it with a capital letter A. So we would name this point P-O-I-N-T and a capital A. Let's look at the next definition. The next definition is line. A line is a set of all points that extend in opposite directions. We have to have arrows on both ends because it has no beginning and it has no end. So I'm going to go ahead and I'm going to draw a picture of a line. It looks like this. There are several points that are on that line. I'm just going to pick out, let's go with 2. So there's a point and there's a point. Let's call this X and let's call this Y. So I can name this line L-I-N-E with a capital X and a Y. I can name it L-I-N-E with a capital Y and a capital X. Or I can do 2 shortcut versions where I put like a little tiny line above a capital X and a Y, or a little tiny line with a Y and an X. And you're going to notice that the little line has arrows on either end. Another thing that you can find when you are finding a line is sometimes they'll go off to the side and they'll have a lowercase letter like that. This instant, I have a G. Sometimes it could be an M or an L. And you can also name it using that lowercase letter. And so what you end up doing is writing L-I-N-E, just like you did before, but this time you're going to use the lowercase g because it is not a point. It's like the whole name of the line. The next definition that we're going to look at is the word plane. Plane is a set of all points. Think of a plane as the ceiling or the floor. It has no beginning, it has no end. It keeps going on in either direction. When we draw a plane in geometry, it's really hard to show that it has no beginning and no end. We normally use it or show it by using a parallelogram. So I'm going to draw a parallelogram, and this would be an example of a plane. And we're going to pick 3 points on this plane. And again, there's several on this. So we can name this plane, plane, and capital letters, A, P, X, or P-L-A-N-E, P-X-A, or plane, A-X-P. There's several of them with the different combinations of those letters. You sometimes will see it. There'll be like a capital letter in the corner, like we'll go a capital M in the corner. And what that is, again, it's kind of like the line where you can go P-L-A-N-E and you can use a capital letter. It's not a lowercase, but it's a capital letter, and it's generally in the corner, and it doesn't have a point that's associated with it. Now let's take a look at a couple of questions to see if you understand what we're doing. So why do we write 2 arrowheads when talking about a line? Well, we do that because there's no beginning and there's no end on a line. It keeps going on forever. How many different ways can you name this line? Well, again, we can go L-I-N-E, A-B, L-I-N-E, B-A, and then, of course, we can do the shortcuts, A-B, B-A, or there's that other special way of going L-I-N-E, and you're going to notice it's a lowercase m because of this m right here. Let's move on and let's do some more definitions. Collinear. Collinear points are points that lie on the same line. So an example of that would be, let's say I have this point, let's call it X, let's call this point Y, let's do this point, which is Z. You're going to notice that they're collinear because if I wanted to, I could draw a line that would go through all 3 of those. Sometimes the line is there, sometimes it's not. It kind of depends upon the situation, but they would be considered collinear. Notice that because they're collinear, they're also coplanar. And you go, what does coplanar mean? Well, that leads us to the next discussion. What is a coplanar point? Coplanar points are points that lie on the same plane. So what does this look like? Let's draw a plane. So here's my plane. Again, it has no beginning or no end. And I'm going to pick 3 points, X, Y, and Z. These points are considered coplanar because they lie on the same plane, like they lie all on the floor or they lie all on the ceiling. They're on the same plane. Just a note, and you might want to make sure you make this note. Those points don't need to be collinear. Okay, so just because they're on the same plane doesn't mean that they're collinear. In the same token, if they are collinear, they do have to be coplanar. So if you have questions on that, make sure you come and see me. Let's move on. A line segment, it's part of a line that consists of 2 endpoints. So what does this mean? Well, it has a beginning and it has an end. And it doesn't have arrows on either end of that. And so let's say, for example, I'm going to name this line segment XM. Again, there's points between them. I can name this line segment XM or line segment MX, or I can do that shortcut again. I can do XM or MX. Now you're going to notice that the shortcut of this does not have 2 points on the end of them. It just doesn't have arrows. And so you know that if it doesn't have arrows, it's going to be a line segment. The next definition that we're going to take a look at is a ray. And when I think of a ray, I think of a ray of sunshine. It's part of a line and it consists of 1 endpoint. So it looks like this. I'm going to start with a point and it's going to go and have an arrow on the other end. So let's say the starting point of this is S, like the sun, and then there's several points going out to the arrow, and we're going to name this M. Okay, so we would name this ray SM, or we can name it like this, where S is the beginning and M is where that arrow goes. Now, here's some questions to think about. First question, is line segment AB the same as line segment BA? The answer is yes, it is. Because again, if I have a line segment like this, it doesn't really matter which end that I start. They would be the same. The next question is ray LM the same as ray ML? The answer is no, it's not. It all depends on the starting point. So in the first one, where it's LM, the starting point would be L, and then M would be out here. The second one, the starting point would be M, and L would be out here. So it does matter with the ray which point comes first. All right, opposite rays. Here's another definition. Opposite rays are 2 collinear rays with the same endpoint. So what that looks like is, again, here's like the sun and it goes out, and then it goes in the opposite direction. And they're collinear, okay? So think of it, it's 180 degrees when it's totally said and done. Okay? Let's go ahead and put 2 points out there. So we're going to call this S, we're going to call this M, and let's call this point P. So I can say ray SM and ray SP are opposite rays. Not all rays are opposite rays. They have to form 180 degrees. So let's take a look at a couple of questions just to make sure we're okay. This one says name 4 different rays in the picture below. Okay, well, I can name ray X, Y. So it's going like this. I can name ray X, Z. So here's my starting point, and it goes out that way. I can name ray Z, Y. So it's going out this way. And I can name ray ZX. Still going that way. So there's 4 different ways of naming some rays in the picture below. Now, what are the opposite rays? Well, if I take a look at this and I look at this picture again, it does matter where our starting point is. And again, think of Y as the sun. So one ray would be YZ, because again, it goes out from the sun. And then the other one would start again at Y, but it would go in the opposite direction, so it'd be X. All right, let's move on. Intersection. Intersection is a set of all points a group of figures have in common. So let's think of it this way. Let's say that I have a line that goes this way, and I'm going to have another line that goes this way. Let's name this M, and let's name this, I don't know, let's name it L. What would be their intersection? The intersection where they cross would be right here. And so let's name that point, let's name it P. So the intersection of those 2 lines is point P. Now, it becomes a little bit trickier when we're talking about planes. And so again, remember with a plane, we're going to use a parallelogram like that. And the plane that comes through this, and it's a little bit hard to see, it's a little bit hard to draw, but what happens is I have another plane going this way. This all should be dotted, this part here. It's kind of hard to see, but really where these 2 planes intersect is a line, and the line runs right through here. And we'll call it G. So where these 2 planes intersect is line, L-I-N-E-G. And again, if you struggle with visualizing it, because it's kind of hard to see and kind of hard to draw, come and talk to me and I'll show you, because if you take 2 pieces of paper and you bring them together and have one cut the middle of the other, it's a little bit easier to visualize. All right, let's move on. Questions. Let's name 3 collinear points. All right, well, let's see if I start with the point X. Here it is. I can go point M and point Z. There's an example. I could also choose point P, point Q, and point R if I wanted to. It all depends on where I started. All right, what is the intersection of the following? Okay, so I'm going to write these down. These aren't actually on the slide. What if I have line A and I have line, and notice it's a different way of writing it, XZ. So let's go back up and let's take a look at it. I have line A, which is right here, and I know that because of that little A. But line A, and then I'm going to go line XZ, this right here. Where did those 2 lines intersect? You can kind of see it. It's right here. And so that would be point Q. You can kind of see where the 2 overlap. All right, let's take a look at the next question. What if I'm looking at plane K and line A? Well, let's take a look at plane K. Plane K, again, is this parallelogram right here. So I'm going to shade it all in because I'm looking at the whole thing. And then what I'm doing is I'm looking at the line, and I'm looking at line A. Now you're going to notice a couple things about line A. Line A has two parts. It has a solid point, and then it has, or a line part of it, and then it has a dotted part. The dotted part, which is right here, what that means is it means that the line is on the other side of that plane. So in other words, the solid part is on the top part of the plane and I can see it, but the bottom part is dotted, which means I can't. So where the two intersect is actually right here, R, and it's penetrating that plane and going right through it. So this would be point R. Again, if you're struggling with that, come and talk to me. I'm thrilled to talk to you about it and show you. If you take a piece of paper and you stick a pencil through it, you can see it a little bit better. Finally, are X, M, and C collinear? Let's take a look at that. I'm going to look at X, M, and C. The answer is yes. They are collinear. Now let's take a look and see, are they coplanar? Well, again, remember that if they're collinear, they have to be coplanar, so that's yes. Again, it must be coplanar to be collinear, but they don't need to be collinear to be coplanar. And so that might sound kind of confusing to you. Again, take a look at some of the definitions, and it really makes a lot of sense. Oh, I'm sorry, I wrote that wrong. This should be up here. X, M, and C are collinear and coplanar, but RMP, take a look at RMP. Here's R, here's M, and here's P. Notice that they are not collinear. So it'd be no. And they are not coplanar because one is sticking up and two of them are on the plane. All right, let's take a look at this. How could you name the front of a cube? Let's take a look at that cube. Here's the front of the cube. It's a plane, so we have to name it with 3 letters. So we're going to go plane, P-L-A-N-E, and I'm going to start with this letter C, so C-D-H. Or I could go plane, P-L-A-N-E, and I could go C-G-H. Or I could go plane, P-L-A-N-E, and I could start with D, D-H-G. Notice that I'm choosing 3 letters. Notice that it doesn't really matter if I choose to start with C or I choose to start with D. What matters is that I don't skip around. So, for example, an example for this would be, let's say that I chose plane, P-L-A-N-E, and I chose the C. I don't go H-D. If you'll notice, that goes like this. You're not supposed to skip around, so that does not work. Name 4 lines that are coplanar with the following. All right. So what happens if I have line DH? So let's go back up with our picture, and let's say I look at DH. This is actually a line. It keeps going on and on and on and on. Okay, so I'm looking at things that are coplanar with it, right? So if it were me, I would take a look at the front of this box. And I could also look at the side of this box because it's touching it. So some examples then would be line FH or line FB, or I could do line DB, or I could go line CD. There's several of them. What if I wanted to choose a different line? What if I wanted to choose the line BA? Well, let's go back up and take a look at this. I'm going to look at line BA, this right here. And so if I take a look at the different planes that touch it, I'm looking at the back of this box or this cube. And I'm also taking a look at the top of this cube. You can kind of see it up there. There's the top. So some points that could be coplanar with it would be like line BD or line EF. There's endless. So line BD or line EF. There's several of them. All right, that's it for the notes. Again, if you have any questions or problems, please feel free to come and talk to me.